Hello, this is Mr. Stansbury. I'm going to take you through the notes on finding inverse functions. At the end of this, you should be able to say I can find the inverse of a function and write the inverse using proper notation. Okay, so first off, an inverse function is a function that undoes the action of another function. Okay. Now, I'm going to give you an example of inverse operations. It's not inverse function, but this will at least kind of give you the idea of what an inverse function is. So if we've got 3x minus 2 equals 10, what we want to do is we want to use some inverse operations here to solve for this thing. So we want to get rid of this this negative 2 by adding 2 to it. That's like if we have negative 2, the inverse of that is positive 2, is adding 2. So we add 2 to both sides, and we get 3x equals 12. And again, a inverse operation here would be, that's 3 times x. So to undo the 3 times, we have to divide by 3. Addition and subtraction are inverse operations of each other, and multiplication, division are inverse operations of each other. So we divide both those by 3, and we get that x equals 4. Okay, so not, again, inverse function, but inverse operation kind of gives you the idea. Let me show you this so you can better understand inverse functions. Okay, so to find the inverse of a function, we switch the x and the y, and we solve for y. That's simply what we're going to do for this thing here. Okay, and then I will show you how that works. Okay, so find the inverse function. We got m of x equals x minus 5. Now, m of x, g of x, f of x, m of t, it doesn't matter. All these basically over here, these are all y's basically. So that's the y equals over here, right? So what it says is we're going to switch the x and the y, and we're going to solve this thing for y. So this y turns into x, and this x turns into y, and then we simply get y by itself. So we add 5 to both sides, and we get x plus 5 equals y. So this x plus 5 now is the inverse function. Okay. Now, just so we know how to properly write use the proper notation for inverse functions here, here's how we write it. So if we've got m of x equals x minus 5, then what we're going to do is we're going to actually write m to the negative first of x is x plus 5. This says that that's the inverse function of m of x is x plus 5. Okay? Now, really quick, let me show you how this works. So this is not what they're asking you to do here, but just so you get a better idea of what an inverse function is. Like let's just say x equals 7. Okay, so if we were to put 7 into this here, we've got into the m of x function. That's what I was trying to spit out there. So that is x minus 5, and let's say we're going to put 7 in here. 7 goes in for 5, so we get 7 minus 5. So out comes 2, right? Now, if I take this 2 and plug it back into the inverse function, I should get my x equals 7 should come back out. Okay, so if I put that in, and our inverse function now is x plus 5, 2 goes in for x, and we get 2 plus 5. And guess what that gives us? 7, which is exactly what we started with. Okay, so that's showing that it is indeed the inverse function, because if you plug it through the function and then back through the inverse function, you'll get exactly what you started with. Okay, so it undoes what another function does. Okay, so if we're going to find the inverse function for b here, we're going to do the same thing. This is y. This g of x is basically y, so we're going to switch that to x, and then this x is going to turn into y, and we're going to solve for y. So we divide both sides by 4. So we get that y equals x over 4. So really, again, our inverse function is, let's see, that was g of x, so it's g to the negative first of x equals x over 4. Or we could actually also write this as g to the negative first of x equals 1/4 of x. Either one of those are the same, mean the exact same thing. So either one of those, whichever one you want, is good by me. Okay? Now again, regardless of what you plug in for x. If you plug it into the function and then you plug it back into the inverse function, you'll get whatever the x was at the beginning. You'll get your value back. And that's what this inverse function is. It's undoing the other function. Okay? So this one here, this is the y over here. So now we'll put x equals 3 times y plus 7. So we got to get the y by itself. So the first thing we got to do is subtract 7 from both sides. So we get x minus 7 equals 3y. And then we got to divide both sides by 3. And we get that our inverse function is x minus 7 over 3. Okay? But again, the proper way to write this is that's f of x. So that means f to the negative, f to the negative first of x equals x minus 7 over 3. That's the inverse function. Okay? Okay. We got one more example, like a word problem thing here. But before we do that, let's take a quick video comedy break here.
My wife has instituted this open door policy where if one of our kids has a nightmare, they're welcome to come in our room and pee in our bed. Luckily, that only happens every night. You ever slept next to someone that's wet the bed? Delicious. You're asleep, right? So when you wake up, your first thought is, oh my God, I wet the bed. Then your next thought is, it's not that wet. I'll just scoot over a little bit. If I pretend to be asleep, maybe she'll deal with it. Oh, I didn't even notice. Hey, while you're up, can you make me a sandwich? Thanks, honey.
All right. Second and last set of examples here. Marty is a professional sleeper. He charges $35 plus $20 per hour to sleep. Sounds like a pretty good deal to me. But first part, A, write a function that shows how much it costs C to have Marty sleep for H hours. So the cost, and I really should be writing this, cost per hour, or like the cost where H is our X basically, and C of H is our Y. So let's see, $35 plus $20 an hour, right? So let's do this, $20 per hour plus $35. $35 must be like traveling fee or whatever. So that's how much it's going to cost, where H is our variable, right? So depending on the number of hours, you can figure out, plug that in and see how much it's going to cost to have Marty sleep, okay? B, how much would it cost to hire Marty for 8 hours? So we would really just do C of 8, and that's just showing that we're plugging 8 into our C machine, the function there, right? Equals, and so really what we're doing is we're doing 20 times 8 plus 35. And let's see, 20 times 8 is what, 160 plus 35 gives us that C of 8 equals, let's see, 195. It's going to cost $195 to have Marty come sleep for 8 hours. Again, sounds like a pretty good deal. C, how many hours could you hire Marty to sleep for $120? Okay, so really what we're doing here is we're plugging 120 in for this over here, and we're solving for H, right? So we've got the cost. Oops. We already know our cost. We're trying to figure out how many hours. So we're going to plug the 120 in for the C of H. So that's 120 equals 20 times H plus 35. So we got to subtract 35 from both sides. Right? We get 20H equals 120 minus 35 is going to give us what, 85? Yeah, so 85, and then divide both sides by 20, and we get that hours is going to be, what, let's see, 85, we'll just plug it in, just to make sure we're good. Pretty sure that's like 4 1/4, but 85, not 80, divided by 20 gives us 4 1/4, so let's see, $120 will get him to sleep for 4.25 hours. That's how much he's going to charge to sleep for. It's going to be $120. Okay. Now, part D, how many hours could you hire Marty to sleep for $100, $200, $150, $250? So we're going to have to solve this thing over and over again. But guess what? If we actually find the inverse function of this, then we can just plug it straight into the inverse function. So if you have a bunch to figure out, it's going to be worth your while to find the inverse of this thing. So if we've got C of H equals 20H plus 35. Now, again, that's our Y, and this is our X, right? So we're just going to swap these two. So I'm going to put, let's do this. Let's do this. Let's do H for hours equals 20 times C plus 35, because really this C of H, that's the Y. So, but I'm just going to put it in as C just to keep the consistent with what we have here. And now we're going to solve this thing for C, right? So subtract 35. So we get H minus 35 equals 20C. Divide both sides by 20. And we get that C equals H minus 35 over 20. But now it's not really the C, right? It's the inverse of this C of H, right? So really what we have is we have C prime of H equals H minus 35 all over 20. Okay, so now, let's see. What this really means is the hours is going to equal cost minus 35 over 20. Okay, so now if we can use this function here, we can plug our cost in here to figure out how many hours that we will get out of that. So instead of having to go through and solve a bunch of stuff. So let's just double check it here with the 120 to make sure that we're good. Okay, because we know that 120 should give us 4.25 hours. So the hours equals, the cost is 120 minus 35 all over 20, right? So if we do that, we will do 120. Let's see, let's even do this. Let's do a little fraction thing here. This will make it easier for us here in the future. 120 minus 35 all divided by 20. And that hopefully gives us 17/4, which is, guess what, 4.25. So we know that that's good. So now when we want to plug in 100, 200, 150, and 250, we can just do this. I'm going to go back up here. There we go. And we push enter here. And then all I need to do here is just go through and edit this one. Or you can just go back and enter everything in if you want, which might be faster because this one's struggling a little bit. There we go. So 100 minus 35 is 13/4, which is 325. So this 100 would be, I'm going to write this in a different color so we can find it easier. 3.25 hours here for that one. Okay, and then we can just do the same thing for 200, 150, and 250, right? So we just go back up, highlight this thing. Come on, there we go. And change that 100 to 200. Or you could do 150, whatever one you want to do first. I'm not sure why I wrote it in that order. So let's do 150. And that gives us 5.75 for this one. Right? And then we can do the same thing for these other two. Okay, so I went through and calculated those out. And here's what we got. We got 8.25 for 200 and 10.75 for 250. Okay? Okay, that's all we have for finding inverse functions. If you have any further questions, please feel free to ask. Thanks.